Hello Calhounians. Our topic today is
The Pythagorean Theorem.
I'm a really big fan of the
Pythagorean Theorem.
so much so that I'm going to put my voice into a robot voice every time I say the words
Pythagorean Theorem.
in these notes today. That way, you don't forget what it's called. Enjoy. So in case you haven't figured it out yet, Calhounians, we're talking about the Pythagorean Theorem. Let's circle the theorem as you've all seen it before. Get some stars by that thing. I want to see those stars on the notes, indicating that you are following my directions exactly. Now, when using the Pythagorean Theorem, what you want to do is always label the sides of your right triangle. Now, A and B don't really matter, but C absolutely matters. You need C to be on our hypotenuse, our longest side. So, example 1 is just us using Pythagorean Theorem. You're going to see me work with the calculator, and you're going to really understand, if we are a little rusty on this, start to finish, what's going on. Now, the only curveball on these notes is that the directions asked us to state our answer in simplest radical form. So we're not just going to go to the calculator, type in the square root of 52, round that off, and get an answer. We're actually going to use what we did a couple days ago, simplifying radicals, to get a solution. We're going to divide by some perfect squares, find some perfect square factors of that 52, just like your assignment from Tuesday. And we're going to end up with that as our value of C. The only difference between part A and part B is that on part B we're actually given the hypotenuse of that right triangle. We're given C. So we can actually plug that value in. It involves just a little bit of algebra, but it also involves simplifying radicals. Pause the video to get the work on part A and part B before you move on. Now, one thing you might not be too familiar with is how to work with Pythagorean triples. And all that means is just numbers, sets of numbers that not only make a triangle, but can actually make a right triangle. Box in that word whole numbers though. We're not worried about a bunch of weird numbers that could randomly come up and make a right triangle. We're talking about whole numbers that we can actually memorize and come back to. One of them being 3, 4, 5. One of them being 5, 12, 13. And one of them being 8, 15, 17. If we were to actually do the math with those sets of values, we would get a right triangle. The directions on number 2 are basically to determine that if the side lengths of these two triangles would form a Pythagorean triple. In other words, as the definition says above, if the sides end up being whole numbers. So what you're going to see me do is on part A and part B, use the Pythagorean Theorem to find the missing value. If the missing value ends up being a whole number, I know that those three whole numbers can end up making a right triangle, that it's possible for them to do that. If not, it's not a Pythagorean triple. You're going to see me do the math, maybe simplify some radicals along the way, but label 1 as a yes, it can be a right triangle, and 1 as a no, it cannot be a right triangle. Now I'm going to throw you guys a bone. Part C and D did not come out real well, as you can tell, so we're not going to do that part. Let's go to the top of page 2. Calhounians, Shipley and I are here together. I know y'all been clamoring to see him in person to talk about our trivia questions. Shipley. I know. Anyway, so the trivia question is this. So Michael Jordan, greatest basketball player of all time, retired from the game of basketball 3 different times. My question to you, when did he do it the first time? Your trivia question for today. In what year did Michael Jordan first retire from the game of basketball? Make Shipley proud. This section involves the converse of the Pythagorean Theorem. Now, if we remember our vocab, our blue friend, converse, all it means is I take an if-then statement and I switch it around. So if the Pythagorean Theorem says that in a right triangle, if I have a right triangle, a squared plus b squared equals c squared, the converse is if a squared plus b squared equals c squared, then I have a right triangle. Get this information down, pause the video, and we'll use this here in a moment. Now the newest thing on this notes, the thing you're going to be least familiar with, is Pythagorean inequalities theorem. I want y'all to take a second to get these 2 boxes down. Make your triangle on the left a little better than mine. That is the world's ugliest triangle. The big take home is that you want to look at c squared. You want to look at the square of that hypotenuse. If that hypotenuse squared is bigger than a and b squared, we have an obtuse angle. Because obtuse angles, the thing about obtuse angles is that they're large. They're bigger than the other 2 angles. If that c squared is smaller than a squared and b squared, we're going to have acute. Because the whole thing about acute is that it's small. It's smaller than something. So look at c squared. on both part A and part B, analyze how it compares to a squared plus b squared, and make that judgment. As soon as we start our homework, this will become a lot easier to conceptualize. But get the rest of the notes down. See you guys in class. And here's the old Calhoun thumbs up. Good work, y'all.